Hello everyone. So in the last video I have explained how you can take a what do you call IR sensor module, pair module, then how you can play around with this. So if you have 4 pins, you can identify the analog out pin, that in another word analog input pin to Arduino. So you can connect it to A0 or A1 or any analog pin of the Arduino, and I explained you how you can keep an object in front of the IR sensor module, and then how you can do the calibration, right? You keep it in a particular distance from the IR sensor. You can measure the distance using a foot ruler or any measuring tape or something, and then you take note of the analog input value that you are getting when the object is in that particular distance, let's say 15 centimeter. Okay, so you know how to read the value, right? You have you know how to write this analog, not these things, how to write this analog read, right? And how to serial print analog read value. That's all you have to do. Then I said, okay, then bring it closer, okay, and find out whether the value is increasing or not, okay, or decreasing or not. We don't know, increasing or decreasing. Then you will obviously one of this will happen, either increasing or decreasing. So you will know, okay, when I'm bringing the object closer, this is decreasing or this is increasing. So when you are bringing the object away, you can do that, or you should do that also. When you are bringing the object away, the opposite will happen, right? Opposite of what happened when you bring the object close to the sensor, the opposite thing will happen when you bring the object away. That is so obvious. Okay, then you will find out, okay, let's assume I'm bringing it closer, the analog value is decreasing. I'm bringing the object away, the analog value is increasing. Okay, and you know the exact analog value when the object is in the particular 15 centimeter or any desired distance you want. Okay, then you will have to write an if condition and else condition. With else condition, if you want to write give an alert or something, that's all you have to do, right? If you just want to monitor the value, then you are done. Okay, you just have to read the value and serial print. Okay, you understand what I'm telling? That's cool. So the connections I explained, okay, you take this and let's say you are connecting to A0, okay, and maybe you can connect a LED to pin number 7, digital pin number 7 if you want, okay, an LED with a resistor, you know that, right? Okay, let's have a resistor, and the other side you will send to ground, and you will connect this +5 to +5, ground to ground, you know all these things, right? Okay, so VCC of this IR sensor module should go to +5 pin of the Arduino, and the ground pin of the IR sensor module should go to ground pin of the Arduino. And if you are going to take the analog input, you don't have to connect anything to the digital input pin. Okay, so let's assume there are 4 pins, and you can see they will obviously write digital out, analog write, or A0, D0, or anything to find out this is digital output pin, and this is analog output pin, or in other words, this is digital input pin and this is analog input pin to Arduino. So you can ignore the digital pin and you can connect the analog pin to A0 or something. Okay, so I explained the code now, I mean connection now. Okay guys, I'm not simulating the connection because I'm not sure whether this IR sensor module is there in the simulation environment. If it is there, I will try to do it in the next video. Okay, so all good. So the code will look like this. You don't have anything. So if you connect this to A0, so you have to say A0 is input because you are going to take an analog input. If you connect an LED to pin mode pin number 7, digital 7, so you have to say pin mode 7 output because that pin number 7 is going to be a output pin. Then you will write the serial being 9600 because you want to monitor the particular analog value of the analog value when the object is in a particular distance. Okay, so you will first serial monitor it. Okay, so you have to serial print it. Okay, because you have written the serial begin already, so serial println x. Okay, so what is the meaning of this? X is the analog read value. That means A0 input value will be assigned to x, and you are printing x. So you know all these things. So now you keep the object and move the object here and there, play around with the thing, and find out what are the values you are getting, whether the value is increasing or decreasing when you are bringing the object closer, or when you are taking the object away from that sensor pair, whether the value is increasing or decreasing. You can find looking at the serial monitor simply. Okay, that's totally good. Then okay, once you found out, okay, let's assume 15 centimeter is your calibration distance, and let's say at 15 centimeter you are getting 250 at somewhere around 250 as the analog input value. So let's say you are bringing the object closer, then you find the number is falling down. Okay, let's say 150, 120, 75, likewise it's going down. So then when you are bringing the object away, so then you find out, let's say the number is increasing, 300, 400, 600, like us up to 2023 this is increasing. Okay, so that's fine. So this will decrease up to 0, let's say, that will increase up to 2023. Okay, so this is taking away, this is taking closer, I assume. Okay, so this may happen the other way around also, we don't know, I don't know, you may test and find it out. Okay, that's fine. So anyway, for the sake of the video, we will assume this is decreasing when we bring the object closer, and this is increasing when the object when we bring the object away. Okay, okay, that's fine. Then you can simply write, okay, let's say you are going to switch on an LED. Okay, switch on an LED when the distance is less than 15 centimeter. Okay, so you will say distance less than 15 centimeter, LED on. Okay, so distance is greater than or equal to 15 centimeter. Okay, that means it's not, okay, less than 15 centimeter. Okay, or in another word, what? Otherwise means greater than or equal to 15 centimeter the object is. Okay, then you will switch off the LED. Let's say this is the task. Okay, so the second thing I am saying, because first thing we are just monitoring the values to get some idea, then I am going to give an output. I am going to alert someone, okay, the object is close by. Okay, like something like that. Okay, so that's fine. So you just have to write an if condition, that's all. Yes or no? Because you found out the exact or somewhere similar analog input value for this. Okay, you found out, let's say 250 is the analog value at the 15 centimeter distance. Okay, so you have to manually put the object at 15 centimeter. You have to measure the distance and make sure this is 15 centimeter just for calibration purposes. Okay guys, so I was explaining this in the previous video also. Keep the object in a place exactly at 15 centimeter from the sensor pair, and then sensor module, then find the value. So let's say this is 250, the value is 250. Then you write an if condition. Okay, if the analog input value is less than 250, then you should find out when we bring the object closer whether increasing or decreasing. So let's say when you bring the object closer, the analog value is decreasing, let's say. Okay, then you will say the analog value is less than 250 means what? The object is closer than the 15 centimeter, because you found out when you bring it closer than 15 centimeter the analog value is decreasing. If it is increasing, you have to do the other way around. Okay, I'm just assuming this is decreasing. Okay, then you will write an if condition less than 250. If the value is less than 250, you know this is distance is less than 250, then you will say switch on the LED. Else, that means what? Value is more than 250, then you know, okay, the distance is greater than 15. Okay, that means you are tested. When you bring it less than 15, the value was decreasing. When you bring it greater than 15, the value was increasing. Okay, then you will write switch off the LED if it is increasing. Okay, that's all. So if this is working the other way around, that means when you bring it closer, value is increasing. When you bring it away, value is decreasing. You have to do the opposite of what I say. You understand what I am saying? Okay, so that's fine. So I will assume this is going to happen. Okay, so then what I will do is I will write a quick if condition. If x is, let's say, less than 250. Okay, so this thing you have to test and find. Okay, increasing or decreasing, that thing. Okay, then you know digital write, I will switch on the LED. Okay guys, digital write 7 high. Okay, else mean what? If condition become false, so that means what? That means what? The value is not less than 250. Not less than 250 means what? Either it is equal to 250 or greater than 250. Okay, at that scenario you will switch off the LED. Okay, so if you see the LED is switched on, you will know the object is within the 15 centimeter range. Very simple. Okay, so you, in another way, you have created a object detector. Okay guys, so this is very simple, right? There's not much, because we have seen a lot of code here. So this coding is very simple coding. So we monitor the value here, we do the alerting scenario here. Okay, very simple. Okay guys, so I will say this is distance is 15 less than 15. You will say more than or equal to 15, or you can say more than 15. Okay, I will add the equal also, because else will anyway cover the equal as well, because here we have only less than values. So else will have 250 and more than that. Okay guys, so this is clear guys. Okay, so I will again recap it in the next video and follow up, so don't worry, just continue, just follow me up in the next video guys. Until then, consider subscribing us and take care. That's all guys, take care.